Hi, Michaela. Welcome to SnapMath again. So we're trying to find the dy dx of all of these things. Okay, so this first one, there's going to be an easy little trick that we can do right at the beginning. What we're going to do is we're going to take the natural log of both sides. So what happens is the e's cancel out and we just get xy equals 2. And then we're going to take the derivative of both sides with respect to x. All right, dx dx. We're using implicit differentiation right here. Okay, so here we have to use the product rule. We'll take the derivative of the first one times the second one, so that's 1 times y, plus the derivative of the second one, which is going to be 1, but times dy dx. Okay, and then times the first one. And then just the derivative of the second side is 0. Okay? So what we get here is we get y plus x times dy dx equals 0. So I'm going to subtract y from both sides. So I get negative y on this side and x dy dx. And then divide both sides by x. Divide both sides by x. So dy dx is just going to be negative y over x. All right, so that's our first one. And this is implicit differentiation. So when you take the derivative of something with respect to x and it's a different variable, you have to tack on the dy dx because of the chain rule. All right? So here we're just going to take the derivative with respect to x on both sides. Okay? So here we're just going to take the derivative as normal, but then you have to tack on the dy dx because of the chain rule. So that's this side. This side is going to be, we're going to take the derivative of the outside function. Okay, we're going to use the chain rule here. So it's secant squared, and the inside's going to stay the same, 3x minus 2y, and then multiplied by the derivative of the inside. So times 3 minus 2 dy dx. Okay? So that's what we have here. Okay, so now what we need to do is we need to get all the dy dx's over to the other side. So unfortunately, I think we're going to have to distribute this term right here to each one of these things. Okay? So what we get is 3 secant squared, 3x minus 2y, minus 2 secant squared, 3x minus 2y, dy dx. Okay? And then this 2y, not dy, 2y times dy dx is over here. And then what we need to do is we need to, actually, I don't want that equal sign right there. We want to have this equal sign right here. I'm going to add this 2 secant squared to both sides. So what we get is 2y dy dx. I'm getting all the dy dx's over to one side, plus 2 secant squared times 3x minus 2y dy dx equals 3 secant squared times 3x minus 2y. Okay? So now what you want to do is you want to factor out the dy dx. So it's dy dx out of both terms. So now it would just be 2y plus 2 secant squared 3x minus 2y over 3 secant squared 3x minus 2y. And then we divide both sides by this right here. So the dy dx is going to be 3 secant squared 3x minus 2y over 2y plus 2 secant x, or 2 secant squared 3x minus 2y. Alright? So that's this whole denominator right here. And this is our derivative. Okay? So now, again, we're going to do implicit differentiation again. So on this third one, what we want to do is we want to take the derivative. So the derivative of the left side is going to be, we take the derivative of the outside function, which is going to be 1 over x squared, times the derivative of the inside function, which is 2x, equals, we're going to have to do the product rule here. So it's 1 times y squared, and then it's going to be 2y times dy dx times x. Okay? So this side becomes 2 over x, and then we're going to bring over this y squared. I'm just going to subtract this y squared from both sides, so it's going to be minus 2 y squared. And then what we have left is 2y times 2y. I'm just going to bring this x over here. 2yx times dy dx. Divide both sides by 2yx. 2yx. So our dy dx equals 2 over x minus y squared over 2yx. Alright, so right here is our next derivative. Okay, and this last one, I don't know if I'm going to have room for it, but I'm going to try. I might have to use this up here. Okay? This last one, what you need to do is we're using logarithmics. So we take the log of both sides, so it's ln y, now natural log, then the log of this entire thing, x plus 2. I'm going to rewrite this as 1 minus x squared 1/2 to the 1/2 over 4x cubed. And then we're going to use our log rules. So it's going to be the natural log of x plus 2 plus the natural log of 1 minus x squared to the 1/2, and then minus the natural log of 4x cubed. So this is our new, with our log rules we can do that, and then natural log of y. There's one more thing. We can bring this exponent down in front right here. So now it's the natural log of x plus 2 plus 1/2 natural log of 1 minus x squared minus the natural log of 4x. And I'm going to bring this 3 down. I'm sorry. It's minus 3 4x. Okay? So now we're going to do implicit differentiation. So this is going to be 1 over y dy dx on the left side. And here it's going to be 1 over x plus 2 times, we're going to use the chain rule, but the derivative of the inside function is just going to be 1. So I'm going to put a little parentheses for that chain rule. We're going to add 1/2 times the derivative of the outside function, so it's 1 over 1 minus x squared, times the 2x. That's the inside function right there. And then we're going to subtract 3 and then times 1 over x times 4. That's the inside function. So we have this one dy dx, but all we need to do to get that, because there was no y's over on this side, is we just need to multiply both sides by y, and we have our function. You might want to do a little bit of adding these denominators or adding these fractions, but we don't have to. So I'm just going to do y over x plus 2 plus, I'm going to distribute this, and there's 2y up here, so it's, or 2x, so it's going to be, oh, well, these 2's cancel out. I'm sorry. I'm going to cancel out those 2's. So it's going to be, just going to be xy over 1 minus x squared. And then minus, this is going to be 12. 3 times 4 is 12. So 12y over x. And that's your derivative right there. All right, Michaela, thank you for sending in your question, and we look forward to answering more of your questions. Have a good night.